Okay, let's try some derivatives that are a bit tougher using the chain rule. So I have three examples on the menu here, and they increasingly become more annoying. So hopefully you have a good time doing these because if you do see them on a test, at least you won't be surprised. So let's take a look at this first example. We have brackets within brackets. So this honestly, using the keyboard is a lot easier with copying and pasting, but by hand, it is a torture to do these. I'm just going to space this out a bit. There we go. So what you want to do is go from the outside in. So we have this square bracket to the 5. So what you would do is bring the 5 to the front. So let's do that here. So there's the 5. And then just raise that bracket to the 4. So now you've dealt with the outermost bracket. Now you want to deal with this stuff here. So we need the derivative of that bracket to the 4, which is basically power of a function rule. And then the derivative of 7x and 1. So the derivative of 7x and 1 is just 7. So basically, we're going to have something like this. Some stuff here. Whoops. I'll just put some dots. I'm trying to put some dots. There we go. Plus 7. Okay. So what you want to do is in those dots there, you just want to put the derivative of that. So we're going to do 4 bracket 2x plus 3 cubed times the derivative of 2x plus 3, which is 2. So this chain rule is 3 layers deep. A little bit difficult to look at, perhaps intimidating. But what I might do is just give it a little bit more color here. So perhaps I'll just take that there and make it blue so that you can just see a little bit nicer. This does simplify, but for the examples that I'll show you here, I might not simplify the first two as much because the last one has a lot of algebra. And by that point, maybe you just get bored of me talking. So let's keep on going on to the next example. Really, though, 4 times 2 is 8 is much the most that you can do here anyway. So, perhaps I'll just do that quickly. So here we go. Let's just make that an 8 there. There we go. Okay, that's enough. Can't help it. All right, moving on to the next one. We have the derivative. Ooh, a root within a root. What's going on here? Now, I talked about this in the previous video. Just a reminder that when you have a root of x, the derivative is 1 over 2 root x. So we can apply that knowledge here to this outermost root first, and I will do that. Again, doing these by hand is painful, but doing them with the keyboard is a lot easier than it looks. So just take that and copy and paste it there. Whoops, I can get it in there. There we go. So we've dealt with the outermost situation, which is this root. Now we have to go and deal with the inside. So we need to do the derivative of this stuff here. So now we're doing that chain rule step. The derivative of root x plus 1 is, again, going to follow this hint here on the side. The derivative of 2x plus 3 is 2. So what I'll do is just put a little dot here to separate the fractions a bit. So the derivative of root 8x plus 1, I will need a square bracket, it looks like. Getting ahead of myself here. There we go. So we'll have here 1 over 2 root 8x plus 1 times the derivative of 8x plus 1, which is 8, plus, so we're still dealing with this local quantity, the radicand here. So we have 2x plus 3, which derivative is just a 2. This innermost root does simplify a little bit. This one here is probably just the tricky one. I'll put that in blue here. People start getting lost when they have these like layers or nested situations, roots within roots, fractions within fractions. It gets a little bit painful to look at. Now this 8 and the 2 reduce, so that will go away. And this becomes 4. But I'll just put the 4 on top here. I'm trying to put the 4 on top here. There we go. We can actually do a little bit more work if you like here. The answer is just fine. If you wrote this on a test, you're going to get full marks on this. This is fine. But if you want to be that extra layer of hero, take that 2 there and bring it over here like that. And then what you can do is bring the half in the bracket. So half times 4 is 2, and half of 2 is 1. And there is your final answer. So that is the derivative of this nested radical function. Very painful to look at, but hopefully that made sense to you. Let's move on now and just do one last example. This is a very classic type of question that you will see in textbooks. And certainly you would see stuff like this on a test. But there's something really cute about this. The derivative of this always follows this beautiful pattern. So when you have two brackets raised individually to powers, they could be integer powers, radicals, doesn't matter. The final answer is going to look like this. So I'm just going to give you a little bit of a spoiler here. It's going to basically look like this. And I'll explain to you in more detail why that's the case. But it will be one power lower, like that. And then you're going to have some stuff here. So now the question is, how do you get that extra stuff? So I just basically showed you how you can caption a whole bunch of marks for just literally one line of writing. But anyway, hopefully your teacher doesn't catch on to the hack there. What you want to do is follow the product rule using each of those products separately. So I will put a bit of square brackets here. We're going to have here 5, 2x plus 1 to the 4 times 2. So that's the derivative of this using the power of a function rule or the chain rule. Then we copy the second one. So there's your product rule in action. Then we leave the first one alone. Whoops. And then we do the derivative of the second one, which I will just do that here. So I'm going to do some copying and pasting here if you don't mind. So that's 4, and that becomes 5 times the chain rule there, which is another 4. Whoops, getting a little ahead of myself with the keyboard. There we go. So that looks scary. That looks scary. But maybe a couple of lines of writing will get us to the situation where it looks a lot easier to follow. So the first thing I'm going to do is just filter out all the stuff that's monomial. So 5 and 2 is 10. And then you have 2x plus 1 to the 4 and 4x minus 7 to the 6. In the second pair here, we have 6 times 4 is 24. And then you have, again, 2x plus 1 to the 5. And 4x minus 7 to the 5. And what you want to ask yourself is, what can I take out from this thing here and this thing here? So definitely 10 and 24 have a common factor of 2. So we can take a 2 out. But you can also take out here, see, you have 2x plus 1 to the 4 and to the 5. So they both have as many as to the 4 in common. Same thing here, 6 and 5. So you can take out as many as to the power of 5. These powers here are not a coincidence. They are always 1 degree lower than the original. And this is because you're subtracting 1 as you do the local chain rules for those power functions. So what are you left with in the brackets ultimately here? Well, let's take a look here. I'll put a square bracket because it's going to get a little bit messy here. If you take a 2 out from the 10, you get a 5 left over. Then you'll have a 4x minus 7. And then over here, if you take a 2 and divide it into 24, you get a 12, and then you have 2x plus 1. So all that remains to finish this question is to simplify the square bracket quantity. So I'll do that now. So 5 times 4 is 20. 5 times 7 is 35. Of course, it's negative. I'm just counting the positive numbers here. 12 times 2 is 24. X, of course, and then there's 12. And we're almost done now. So we can clean that up a bit further as 44x minus, and then you would have 35 minus 12 is 23. And that's the answer. Yeah, that could be a round bracket, but you know what? The video's gone well. Did it in one take. Happy to move on with my life.